Alright, well I hope you enjoyed that time lapse, and if you're still here, I guess that means you want to know a bit more about how this thing works. So, I guess I'll spend the next few minutes trying to explain a few of the different colored circuits that are in this 15 puzzle. So I guess I'll begin with this light gray circuit over here. And this is the input, and what it does something special. So you can see, we have all these buttons here, but how's it only sending it through one wire? And I do that with something called serial, and it basically, each input sends two pulses a slightly different delay apart from each other, and it's able to then decode those pulses into the different inputs under here. And so that's the input, and then the next few circuits are more just wires that are for the different moves. So the red wool is for moving the tile up, yellow is for moving the tile left, green is for moving the tile to the right, and finally blue is for moving the tile down. And so a few more of the circuits. This dark gray wool, you can kind of see down here actually, is going to clear all of the cells. It's going to make all the cells empty. And then this is used not only to just completely clear the board, but also to prepare to send the completely solved state to the board if you press the solve button, if you're a bit of a sneaky cheater. Or if you press the scramble button, it'll activate this cyan circuit, which will copy the memory from the scrambler into the main cells. And I'll get to the scrambler in a bit. So these next group of circuits are more for actually moving the tiles, all the logic behind that. So this pink wool kind of acts like a filter. So if I showed you a clip of the red, yellow, green, and blue wires, you can see they're kind of all over the place. And this pink acts like a filter to only activate whichever cell is relative to an empty cell that you want to move, instead of activating all of the cells at the same time, which is not kind of what you want to do. And then light blue is, so while you're making a move, it's going to copy whichever cell you're trying to move and move it and paste it into the empty cell. And then, so now you have two the same number. Well, you gotta get rid of the old number then. And that's what blue does. It gets rid of the previous location of the numbered cell that you're moving. And then orange is what actually stores all of the data of the cells. It's just two comparators facing into each other, and that can store signal strength, and that's how I store the data for all the cells from 0 through 15, which is conveniently all of the signal strengths that Redstone can have. And then this magenta circuit is what actually checks for a solved board. And if it's solved, it's gonna do that whole fancy lighting effect that you saw at the beginning of the video during that time lapse. And then finally is the brown circuit. And now this is kind of the heart of the scrambler here. And what it is a randomizer that can output 1 through 4. And depending on the output, it's going to send a certain signal to the scrambler. And now what the scrambler is, how I was able to make the scrambles be always solvable, is I was a little sneaky. I created an exact copy of the circuits that I use that actually move the cells around. And so there's kind of a second board in here that's dedicated to storing the scramble. And now what one of these pulses made by the brown circuit does is it makes a random move on this kind of hidden board. And so it's going to randomly move the cells around in order to scramble it and to have an always solvable scramble, because it's always going to make a valid move just completely randomly. And so that's what the cyan circuit kind of copies from. It copies from the cells in the scrambler and moves them to the actual board so you can mess around with the scramble and try to solve it. And that is kind of all. I mean, there's obviously one more thing here, and that is this display. And I think it's a pretty cool circuit. I'm kind of proud of it because I designed it myself from scratch. But it's a display that can show signals 0 through 15 and show it up as a number. It's either blank, 1, 2, 3, 4, 5, 6, etc., etc. And that is what shows the numbers from whatever signal is stored in the memory. It kind of decodes it into a number that you can see. And that is all of the circuits that kind of make this thing work. And yeah, I hope you liked watching this. I will try to put a world download in the description. I mean, I've never tried to do that before. But if it's not there, you can harass me in the comments and I'll try to put it there. But I don't know how to end these things. Thank you for watching. Smash like. Yeah.
Lol.